All right, we're going to continue with our little talk on uh, equation of a line. All right, so what was the name? What was the formal name of the equation of a line we learned yesterday? Does anybody remember? Yeah, well, slope-intercept form. Slope-intercept form, right. Slope-intercept form. And how would you write slope-intercept form, just as a brief review? Yeah. Okay, so yeah, that's a pretty popular thing, isn't it? We're going to learn another one today, but we're also going to talk a little bit more about this. We should have talked about this when we talked about slope, and for some reason it just slipped my mind, but we'll talk about it right now. If I had a line that was a horizontal line, I'm not going to draw an x and y axis, I'm just going to show a horizontal line right here. Let's think about the slope of this line, all right? The slope of a horizontal line. Let's just put some points on the end of this, all right? And I don't know where it is. Let's say this is at, it doesn't matter. Yeah, I guess I should have done an XY axis, but that's okay. Let's just say this is 2, 0, and this is, I don't know, 7, 0. And we want to find the slope of this. All right? So what is the slope? It's the change in what? Y over the change in X. And what does that mean you do? You subtract the Y's and then you subtract the X's. Agreed? So let's subtract the Y's. So what are my Y values here? It's a horizontal line, so this is 2, 0. This is 7, 0. So it's what? 0 minus 0 is 0. And then 7 minus 2 is 5. Everybody with me on that? Or you could have gone 2 minus 7 is negative 5. It wouldn't make any difference because what is 0 divided by anything? It's 0. So what is the slope of a horizontal line? It's 0 slope. Now that means that there is a slope. That does not mean that it doesn't exist. It does exist. All right? Arturo is a fantastic skier now. All right? He's gone one time. And really, he did really well. You wouldn't believe it. Him and Luis, they hadn't been skiing before and barely had seen snow before, right? So really, that's probably the first time you've been on anything slippery like that. Have you? Maybe you went sledding. Did you go tubing or sledding when you had snow before? No. So it's the first time he's ever been on there. So they got on what? What was the first thing? What was it? Snowboard. They got snowboard first, and I tried to talk you out of it, didn't I? I told you, I said, if it was my first time, I would go skis and work your way up to snowboarding. But they went snowboard, but it was pretty quick, right? Maybe how many times down did you go? Just once. Okay, that's all it took, right? So he went one time down on snowboard and said, "This is not for me," and they went to skis. By the end of the second day, he was both of them went down with me at the very top of the hill and went down the very hardest hill that they had. And they went down without even falling. And they went down quick, too. I mean, I went down pretty fast, and I had to wait for them. I mean, they were right behind me. And so anyway, so he knows all about skiing and slopes and all that kind of stuff now. Okay, he's a professional. But what about this? This was the easy part. Okay, this was the easy. Well, for most people, it was the easy part when it was flat right there. I still saw some people falling. Gabby, you're smiling. Did you fall on a flat part like this? Maybe. But this is yeah. I got video. Actually, I got video of both of you. I think falling. Yep. So this right here was usually the easiest part, but it was still a slope. I mean, you go out there, and there were flat parts, weren't there? There absolutely were flat parts. So how do I remember that this is zero slope? Well, I do remember it's a slope, okay, but I also know that if I just stood here, I knew that if I just stood here, how fast would I go without being pushed or the wind blowing me or anything else? If I'm, watch this, here's me. Boom, boom, boom. There's me. Whee! Right, and there's my skis. Look at that. Isn't that a great picture? That's the tip of my skis. Right? And then probably they go back a little bit, right? Anyway, there we go. That's weird. Looks like I'm in a boat or something. Looks like I'm paddle boarding. You ever see that, paddle boarding? Anyway, I'm on skis. That's what I'm doing. Oh, here's my poles. Here's my 2 poles. All right, there we go. So if I'm just standing there, it's a completely flat surface. How fast am I going to go? Going to go 0 miles per hour, correct? Now, it's still a slope. It still exists, doesn't it? Didn't you see places when you went skiing that were flat like this? Absolutely. It still exists, but the slope is 0. So the slope equals 0. 0 is something, and I'm getting to a point here. All right, the slope is something. It's 0. It's a 0 slope. And you understand why it's a 0 slope, don't you? Because you subtract the y's, you get 0. Subtract the x's, you get whatever number. Doesn't matter. But this does exist. You do get a 0 slope. All right? So anytime you have a horizontal line, the slope is 0. Now, what if you had this? Let's go blue. And Brandon was a good skier. He went up there. You skied, right? Or did you snowboard? You skied, right? You did both? Okay. Um, did you go to the very, very top? Did you ever see a slope that looked like this? So here you are. Here's me again. Boom, 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 boom. Right? And there's your skis, right? Yeah, kind of looked like it. But once you looked over the edge, did it go completely straight down vertically like that? Did it? It didn't. And you almost felt like that in your heart. That's right, exactly right. And that's exactly what I want you to see. Because look, if you went down something like this, you would go boop, 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 all this, and then bang, you'd just be a big mess, wouldn't you? You wouldn't even exist anymore, would you? Not on this world anyway. All right, you wouldn't even exist. All right, so let's talk about the numbers for the slope of this. Watch, let's take this point and this point right here. Pretend we're on a XY axis. So this is like 0 whatever, 0, 3, let's say. And this point right up here would be what? 0, who knows, 10 we'll call it. All right. So what if I wanted to find the slope of something that looked like this? A vertical line, isn't it? It's a vertical line. So let's find the slope. So what do? We subtract the y's. It's the change in y over the change in x. The change in y is 10 minus 3, which is 7. The change in x is what? 0 minus 0, which is what? 0. What is 7 divided by 0? It's undefined, isn't it? Guess what you would be down here if you actually went down something like that? You would be undefined. They probably wouldn't be able to tell who you were even, okay? Might have to do dental records or something, who knows, if depending on how high the hill was, okay? But you would be undefined, all right? Does that make sense? So does this even exist? Would you ever, even if you went to Colorado or go to Vermont or go to wherever, to Vail or something, you go to the Switzerland, I don't know who's got the biggest and the best ski place, but you go there, will they ever have a sign that says, they might have 10 black diamonds, all right? We just went on one black diamond. A lot of places have like double black diamonds. Are there enough black diamonds to actually go down something like this? No, there's not. They would never point you in this direction. Okay, now there are hills that look like this, but do they tell you to go down it? No, they tell you to stay. They tell you to stay away from these. They have them usually roped off or fenced off or something like that, so you don't go down something like that. All right. So what's 7 divided by 0? We said it's undefined, right? So you could say it's undefined. It's not 0, is it? Put that in a calculator. 7 divided by 0 is not 0. It's undefined, or you could say it's this. You could say it's no slope. No slope is different from 0 slope. 0 slope actually exists, okay? You can ski on 0 slope. That does exist. But this does not exist, okay? There are no slopes that look like this. So we say that this is no slope, or it's undefined. Either way, I would accept. All right, so if I had a vertical line, that means all the x's are the same. So if I gave you this, if I said find the slope between 3, 2 and 3, negative 5, what kind of line is this? I go over 3, go up 2, and I go over 3 and go down negative 5. What kind of line is this right here? Okay, it's undefined. Well, you're actually telling me what kind of slope it is. I'm asking what kind of line is this? It's a vertical line, right? Okay, it's a vertical line. All right, so what kind of slope does a vertical line have? It doesn't have a slope, does it? It's undefined, or it's no slope. That's different from 0 slope. You follow me? So if the x's are the same, think about it. I'll just quickly do this. 1, 2, 3, 1, 2, right there. And then 1, 2, 3, negative 5 would be right there. They line right up on top of each other, don't they? So that's a vertical line. A vertical line has no slope, not 0 slope. And I've said this a lot today because people get confused between the two. It's no slope, or it's undefined. I would be happy with either one of these that you said right there, okay? No slope or undefined slope. Make sure you understand that. There's a huge difference between that and this, isn't there? 0 slope is just a nice horizontal line, all right? So what if I asked you this? What if I said, okay, what if find the slope between 2, 3 and 5, 3? Look at this. what kind of line is 2, 3, and 5, 3? It's a horizontal line, right? So if I go 2, 3 right there, and I go 5, 3 right there, you got a horizontal line, don't you? So what kind of slope is a horizontal line? It's a 0 slope, right? And you could always do the math if you wanted to, right? The change in y, 3 minus 3 is 0 over 5 minus 2. 0 over 3 is 0. It's not undefined. It's not no slope. 0 is something, all right? It's on the number line, isn't it? It exists, all right? This does not exist. I got a second. I always tell a story about this. Do you mind?
Sure.
I was actually on something like this, but I didn't have skis on. I was strapped up in a rope. I was in ROTC in college, and we went to where did we go? To VMI, which is Virginia Military Institute, and it was just a day trip. It was on a Saturday, and we did a hill. We did a warm up hill that was kind of like that, and it was on dirt, and there was trees around. It was real easy. I mean, you could walk down that thing. But what we did was we rappelled, right? And so we just did this just to practice the whole rappelling thing. So we did that a few times. That was a piece of cake. I'm like, ah, this is easy. Then they took us to a place like this, and it was all rocks. I mean, there was big, huge rocks down the bottom, okay, and big old piles of rocks. I mean, that's all it was. And this was a sheer vertical cliff, okay, and it was all stone. It had been broken out, I don't know, but all these boulders down here. So here I was up at the top and strapped up in a rope. It wasn't even like a real harness. It was an actual, just a long piece of rope, and they called it a Swiss seat or something like that. They showed you how to get it all, and it was a little uncomfortable, but it was nice and tight. It was nice and tight, so you wouldn't fall out of it. So I was at least happy about that. I was very happy to take the thing off though after you're done. Anyway, you give the other, and you'd hook up to this rope, and they had this like metal thing right there, hook onto it, and so I'm like this. This is me, and you go backwards, right? So you're facing this way, up the hill like this. So I was literally, let's see if I can draw me. Okay, there, I was like this, and that's me, and I was hanging on to the rope, right? There's the rope right there. There's no lie. I was completely perpendicular. I was perpendicular to this mountain. At least I thought I was. And the guy, and what you put your hand, you took this rope and you put it behind you. And it was a pretty cool little invention, right? And so all you had, if you just let up just a little bit, you just took the rope, and it wasn't really hardly any pressure at all. You just let up the rope, you would slide down. All you had to do was take that rope and put it right behind the small of your back, and it would make you stop. It didn't take any strength or anything. It was pretty simple. Um, so I know I was vertical or horizontal like this, but the guy's like, you got to let out a little more, little more, little more. And I was thinking, oh my goodness. And so now, no lie, I know I was like this. Maybe I wasn't, but I know I was like this. I felt like I was like this. And so if you keep going down, what's going to happen? You're going to lose footing, right? You're going to lose footing, and then guess how I ended up? I was completely like this, okay? And I was completely, I wasn't falling, but I was still hung on the ground. I was completely upside down. My feet were straight up in the air, and all these people, there was a bunch of people, and guess where they ended up? They ended up looking over the hill. Well, I can't even draw a stick person anymore. I'm getting so nervous. I'm getting so nervous recalling this event. So everybody's peeking over the hill, and this guy who's from VMI, he's this Army Ranger guy. I mean, these guys are crazy, crazy guys, and I thought I had a little bit of adventure in me, but these guys just topped anything that I ever thought I would do. But they're all yelling and screaming at me, don't move, whatever you do, we're coming down. And they're all getting hooked up, right, to try to come down and get me. And I wasn't that far. I was only just a few feet down below the top of this hill thing. And I was like, oh my goodness, I saw all these people looking over the edge, at me like, oh, I wonder if he's going to die, So there's no way I'm going to let this guy come and rescue me, right? I was so embarrassed. And so I wasn't even scared. I was more embarrassed than anything. So somehow I got my feet against this, and I just kind of pushed, and I rocked back and forth until finally got my feet underneath of me. Underneath the rock, and then they're like, no, don't move. And so I finally got where I was supposed to go, and I just went, it went like this. I mean, it was pretty far down. This is not exactly the scale, but I was here and I just went boing, 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 just down. And everybody else was doing like 10 times. You know, they'd go down a little bit, hit their feet, then they'd go down a little bit because everybody else was kind of going like this, right? Going a little bit at a time. But I made it down really quick after that. I mean, I just kicked off and kicked off again, and then finally got to the bottom. And the guy at the bottom was like, he's like, well, you got off to a little bit of a rough start, but you were probably the fastest one to get down here. I was like, yeah, no joke, because I wanted to get away from everybody because I was so embarrassed. But anyway, so that's my no slope, okay? And if I would have fallen right here, I definitely would have probably not been identified. I would not exist, okay? So there you go. There's my, I always save that story for, I just think that's funny. I wish I had pictures or video or something back then, but nobody carried a camera back then. Not too often. All right, anyway, so we've talked about that. Let's talk about another thing. Let's talk about the X Intercept and the Y Intercept. We mentioned that briefly, but what if I give you a, let's say the X Intercept is 3 and the Y Intercept is -5. And you want to find the equation of this line. All right, so we want to put it into this. So you're going to have a couple problems. You're going to have to do this. Well, first of all, if you know 2 points of a line, if you know 2 points on a line, you can find the equation of the line usually pretty easily. But what are the points there? Well, let's think about it a little bit. Let's think about where these points are located. Remember, they're intercepts. It's where they cross the axis, right? This crosses the x-axis where? At 3. So that would be it right there. That's that point. Now, you don't have to graph these. I'm just doing this so you can visually see what's going on. What's the y-intercept? It's -5. 1, 2, 3, 4, 5. And that point would be right there. So what are the actual points? What's the actual ordered pair of this x-intercept right here? It's not just 3. What is it? It's 3, 0. Good. And what's the actual y-intercept to this point? 0, -5, isn't it? So if you see x-intercept, you could just write this how? Just 3, 0. And if you see the y-intercept, you could always write that 0, -5. Everybody see that? So when they give you an x-intercept and a y-intercept, that's all you have to do is just make it into the actual ordered pair. And if you don't remember which one goes first, does the x go first or the y go first or whatever, you could always graph it, and that gives you general idea of how to do this. Now, how would we do this thing? Well, look, they already tell you one thing. Out of this slope-intercept form, what do they tell you right off the bat? They tell you the what? The y-intercept. That's right. So they tell you that. You don't even have to do any math to solve for that, do you? They tell you what the y-intercept is. So really, what's the only thing you really have to find here? It's the slope. Exactly right. So now let's just find the slope. I've got 2 points, don't I? And now we should be able to find the slope. So the slope, again, is the change in y over the change in x. So let's subtract the y's. 0 minus -5. And then subtract the x's in the same order. 3 minus 0. Let's see what we get. 0 minus negative is +5. 3 minus 0 is 3. So the slope is 5/3. Now we know what the y-intercept is. They told us what the y-intercept was. It was -5. And now we know the slope. Let's put the two things together. And if I put the two things together, then I've got the equation of the line. And how do I write that? Y equals m. I just found m, so what is that? 5/3. And we put an x, and then we put the y-intercept. What's the y-intercept? -5. And there you go. That's the equation of the line, this line right here. So if I wanted to, now again, you don't have to graph this to do it. And I would suggest you don't graph it because it's just a little time consuming. All right. But that's the equation of that line right there. Make sense? All right. Let's do one more thing. Actually, it's kind of one thing, but it's 2 parts to it. Let's talk about parallel and perpendicular. Parallel lines and perpendicular lines. Perpendicular lines. All right, let's talk about 2 lines that are parallel to each other. So there's one and there's another one. What do you think might possibly be true about the slopes of 2 lines that are parallel? They're exactly the same. Exactly right, okay? This isn't slanted any different than this, is it? All right, it's got the same exact slant. Now, one might be up a little higher than another one, but the slant is exactly the same. The slope is the same. So for parallel lines, the slopes are the same. All right, so we'll just put equal slopes. Or you could say that the slope of line 1 is equal to the slope of line 2. Does that make sense? All right. So what if we had this? What if we had y equals 3x plus 2 and y equals 3x minus 5? Just looking at this, what can you tell about these two lines right here? We don't say they're equal to each other. Lines can't really be equal to each other, but they are what? They're parallel to each other. That's right, they're parallel. How do you know they're parallel? Because they have the same slope. If they have the same slope, we know that they're parallel lines. Make sense? Perpendicular lines, a little bit different. Just draw it like that. Now, what does that mean to be perpendicular? It means form a right angle, correct? Now, look at these two lines right here. Do they look like the same, parallel to each other? No, they're not. So the slopes would not be the same. In fact, one's positive and one's negative. This slope right here is a positive slope because from left to right it's going up. Look at this slope right here. What is that? That's a negative slope because from left to right it's going down. So one's positive and one's negative. That's always going to be true about perpendicular lines. Perpendicular lines, one's going to be positive and the other's going to be negative every single time. Okay? Here's something else. What if this slope right here was like 2/3? So the slope of this line right here was 2/3. This one right here, I'm not going to go any reasoning why, I'm just going to tell you. The slope of this one is the reciprocal of this one. See how that's a lot steeper than this? Well, it's steeper by the inverse. They're inverses of each other. So if this slope was positive 2/3, what's this slope going to be? Negative 3/2. Everybody see that? So they are, I use this phrase, they are negative reciprocals. Now, some people might use different words, but this is how I like to say it. They're negative reciprocals. Negative meaning opposite signs. So, for instance, if I gave you if I gave you negative 5/7 x plus 2, and then I said y equals 7/5 x minus 3, look at these two lines right here. What could you tell me about those two lines? That they are what? Not parallel because they're not the same. They're perpendicular. Everybody see that? They're perpendicular because the slopes are negative reciprocals. One's negative, one's positive. This is 5/7 and this is the reciprocal of 5/7. It's 7/5. Does that make sense? Okay, so that should help you out a little bit. And I think we pretty much covered everything. All right. Now, you'll probably have some questions on this stuff. So, we'll hit some of those questions. But I want you to really do your best at doing these problems. And then tomorrow we'll do a little question and answer day. And we'll go over some of these things. All right? Tiffany, here's your paper.
Thank you.
Thanks for listening to my dumb stories about my brush with death. But I'll do both of them. Both sides.